Hello guys. So today we are definitely going to learn something new, that is reactions of ammonia. We have already prepared ammonia. We have prepared ammonia liquor by back suction experiment. You remember, by inverted funnel arrangement. Right? We have avoided the back suction of ammonia by inverted funnel arrangement. We have also studied about fountain experiment. We have studied in detail about Haber's process. It's time now to understand the chemistry of ammonia. How does ammonia molecule behave in differ with when it comes in contact with different kinds of molecules? So definitely to understand this, first of all we have to understand the ammonia molecule itself. So let us draw the ammonia molecule. So this is the ammonia molecule. Three covalent bonds with hydrogen, and it has a lone pair of electron, right? Definitely if it has a lone pair of electron, it can donate it. So ammonia is a ammonia is a electron donor, correct? Ammonia is a electron donor, is a electron donor, and whoever is an electron donor is definitely proton acceptor. Proton acceptor, ठीक है, that is H plus, ठीक है. Why H plus is called proton? Because see, if it is hydrogen, then it has one proton, zero neutron, and one electron. If we are talking about H plus, then definitely proton will be one, zero neutron, zero electrons. Clear? So that is why if you can see, this H plus is nothing but a proton. Hence, it is an electron donor. It is also a proton acceptor. But how does this help us in understanding the chemistry of ammonia? देखो, ammonia donates electron. Good electron donors are definitely good bases. Okay, number one. So it will have basic nature. Number two, reducing agent. Electron donors means they are good reducing agents. Okay, so ammonia is a good base, number one, and number two, ammonia is a reducing agent. If somebody asks you why ammonia is a good reducing agent, your answer should be it has a lone pair of electron which it can donate, and hence being a very good electron donor, it is a good reducing agent. Now, how does this really help me in understanding the chemistry once again? So definitely with these two things we can understand many reactions of ammonia. Let's see. Number one is with acids. Acids means, let's take HCl plus NH3. It will give you nothing but NH4Cl. This is a reversible reaction, NH4Cl. This reaction is very important and used as a test for both ammonia and HCl. Okay, so it is a salt, definitely acid plus base will give a salt. So this shows basic nature of ammonia. Okay, and this has a characteristic dense white fumes. ठीक है, dense white fume characteristic. ठीक है, it can be used as a test for ammonia. Test for ammonia. How? Suppose in a glass rod, now this is ammonia. ठीक, ammonia. Suppose there is a jar of ammonia gas. Now a glass rod, ठीक है, glass rod, dipped in HCl, you bring this glass rod in this one. Okay, in contact with ammonia, it will give dense white fumes, which gives us clear-cut indication that this glass jar had ammonia. Okay, this glass jar has ammonia. So this is just one reaction with acid. You can react the same like NH3 plus H2SO4. So 2NH3, you will get NH4 whole twice SO4. Okay. Similarly, if you want to do it with nitric acid, then also it is very easy. NH4NO3. Okay. So definitely, now there is a question that can come into your mind, sir. It is a base, it is a acid. You are only forming salt. What about water? See, ammonia is a base. I agree. It has basic nature, but it is not exactly a base. It is nothing but basic anhydride, basic anhydride of ammonium hydroxide. So if you take water out of this ammonia liquor or ammonium hydroxide, then you will get ammonia. So once you have already taken the water out, then this water is not going to get formed, only the salt is going to get formed. So ammonia reacting with any acid as a gas, if ammonia is the gas present there, then definitely it will give you salt only. So with acids, ammonia will give salt. Remember, with acids, ammonia will give you salt. Okay, clear? Okay. So next is, so at this moment, if somebody asks you which nature is shown by ammonia over here, then the nature shown in all these three reaction, nature shown by ammonia is nothing but basic nature. Which basic nature is demonstrated over here. I hope this is absolutely clear, the first part. And now we'll be studying the reducing nature. Okay, now we'll be studying the reducing nature. Also, there will be certain reactions where we will study both the reducing nature, also the acidic nature together. So first of all, let's go for reducing nature. So number two, the following reactions will demonstrate the reducing nature of ammonia. Reducing nature. Reducing nature of ammonia. Now see, if it is, we will talk about two reactions over here. Again, these reactions are very important from examination point of view. So first is copper oxide plus NH3. Okay, so let us understand this reaction. Let us find out the products rather than remembering the products. See, copper oxide is an oxide. It has some oxygen. Ammonia is a reducing agent. So definitely if ammonia want to reduce copper oxide, then what it will take out from copper oxide? Definitely it will take out the oxygen and copper will remain as behind. Now this is what agent? This is reducing agent. And this is at this reaction, if this is reducing agent, definitely this will act as oxidizing agent. So when the reducing agent is reducing somebody, it itself gets oxidized. So ammonia, if you see, contains hydrogen. So if you need to oxidize this ammonia, you have to take out the hydrogen. Then what is remaining? Nitrogen, right? So you write plus N2, plus N2, plus. Next, now you are left out with two things. यहाँ से आपने ऑक्सीजन निकाल लिया था, यहाँ से आपने हाइड्रोजन निकाल लिया था. हाइड्रोजन और ऑक्सीजन मिलके बनेगा पानी, वाटर. ठीक है? Now you can balance this. It's very easy balancing. ठीक है? So here in this reaction, if you see, copper oxide is getting reduced to copper and ammonia is getting oxidized to nitrogen. ठीक है? Very important reaction. Huh? Very important, which gets reduced, which gets oxidized. Reducing agent gets oxidized, oxidizing agent gets reduced. I hope it is clear. And this kind of reaction where both reduction and oxidation takes place are called redox reaction. Redox reaction. Other question that can come in this reaction is definitely the color part. See, this color is black. This color is black and copper color is reddish brown. So definitely somebody can ask you about the observation of this reaction, then you need to write that black color copper oxide changes to reddish brown. Black color changes to reddish brown. Okay. So there is another reaction similar to this. Okay. That is with lead oxide. That is PbO litharge plus 2NH3. Same reaction. Nothing changes here. Just you can replace lead in place of copper. Nothing else. So that's it. But here also people can ask you that what is the color change. So observation is important. Yellow to silvery white lead. Silvery white, sometimes silvery gray. Silvery white I'll write. Okay. Silvery white. Okay. So this is again the same redox reaction, nothing else. Okay. Color change is very important, and in both this reaction you need to heat. Heat is very important. Actually what happens, there is a tube like this. Okay, tube like this, in which suppose this copper oxide is placed. Okay, CuO, and with a pipeline ammonia is passed and it is heated with a Bunsen flame. Okay, and this color changes. This way the ammonia is passed and nitrogen goes out, and this color changes from black to reddish brown. Okay, clear? Okay, so we have now under the same reaction can also happen with ZNO. I am not showing that. You can do that. I suppose that just replace zinc with lead and that's it. Nothing else. Okay. So now we have covered up the reducing nature of ammonia also. There are certain reaction wherein we will get both the type combining together. You'll get both kinds of these natures are getting exploited. So such a kind of reaction is reaction of ammonia with chlorine. Very important. We'll take that in next slide. So very important reaction number 3. Understand very well. We don't remember reaction. We try to understand them. Reaction with Cl2. Okay. So see, first of all, I'll write ammonia and I'll write chlorine. So what does it form? See, if this compounds ammonia and chlorine as a molecule, you can clearly say that this is a reducing agent, and you can say this is a oxidizing agent, or you can also say this is a base, and you can also say this is acidic in nature, right? So both the things are taking place over here. So supposedly you are asked base and acid होगा तो तुमने क्या किया NH4Cl बना दिया. गलत हो जाएगा, गलत हो जाएगा. HCl होता तो हो जाता है NH4Cl. Now this is only Cl2. Cl2 will act as an oxidizing agent over here, and ammonia will act as a reducing agent. Now if ammonia is acting as a reducing agent, then what will happen to ammonia? Ammonia itself will get oxidized. So if ammonia gets oxidized, what it loses? It loses hydrogen and it is left with N2. And suppose this Cl2, Cl2 definitely is an oxidizing agent, it is going to get reduced. Cl2 का रिडक्शन करोगे तो कैसे करोगे? यहाँ पे हाइड्रोजन हटा दिया था ना, हाइड्रोजन का साथ Cl2 जोड़ दो, so you will get HCl, and definitely you need to balance it. ठीक है? So this is the primary reaction. So many times we are asked that what happens if this reaction is done with excess NH3. Don't worry, do it like this. First you write the previous reaction, 2NH3 plus 3Cl2 gives N2 plus 6HCl. Next what happens? Next you give excess NH3, right? You give excess NH3. Now this NH3 definitely will not react with N2. N2 is an inert gas. It will react with HCl very well. Acid, normal acid base reaction, 6HCl. So I'll take 6 NH3 and I'll get 6 NH4Cl. What I do after that, I just add the reaction. I get 8 NH3 over here, and this 6 HCl basically can be cancelled out because I have used this 6 HCl produced, nothing else. So here it is 3Cl2, N2 plus 6 NH4Cl. This is happening if you are using excess NH. Now what happens if you use excess Cl2? What happens if I use excess Cl2? ठीक है, वो भी करेंगे. So first of all, let us write the primary reaction. Primary reaction is same, 2NH3 plus 3Cl2 gives N2 plus 6HCl. Now you are giving excess chlorine. Excess chlorine will definitely not react with HCl. ठीक है, HCl के साथ क्लोरीन क्या, ये भी एसिडिक रिएक्शन नहीं करेगा. It will react with N2. And if nitrogen reacts with chlorine, then what compound can it form? Cross multiplication कर दो यार. नाइट्रोजन का 3 वैलेंसी, इसका 1 वैलेंसी. It forms an yellow explosive liquid NCl3. It forms a yellow explosive liquid NCl3. ठीक है, plus HCl. Okay, this is done. No need. Okay. Now what you can do is you can definitely add these reactions. Okay, because you have used this. Okay, you need to balance this, right? So this is 3Cl2. So this will be 2NCl3. Okay. Now it is 2NH3 plus 4Cl2. Nitrogen will cancel out. Gives 2NCl3, 6HCl. Now you cannot leave it here because it is an overbalanced reaction. So you need to just make this balancing correct. Final one. You need not write it here. You can write in the next line. I don't have space. That's why I am using it here. So NH3 plus 3Cl2. Okay, 3Cl 336 was there. Sorry. So here it is NCl3, and here it will be 3HCl. Done. Don't try to remember this reaction because remembering can help you at this moment of time. Later on, it will create a lot of problem. This is yellow explosive liquid. Okay. This will be important because if observation is asked in this reaction, please write yellow liquid is formed, and if observation is asked in this reaction, please write dense white fumes are observed. Okay. All are important things, please note down. Okay, so here on we have finished the reactions which matters. Basically these reactions really matter with respect to oxidizing agents, reducing nature of ammonia, then your basic nature of ammonia we have covered. Another very important reaction now we are going to do is in the next slide. I'll do. So this is reaction with carbon dioxide. I'll first write the reaction. 2NH3 plus CO2. Here on you have to give 150 degrees Celsius is high temperature is required. 150 atmosphere. And H2 plus H2. So this is nothing but urea formation. Now how this reaction happens, that is important to me. This is carbon dioxide structure. Okay, and this is your ammonia structure. Okay. So this is simple reaction. Just water goes out, and this is how the bonds are replaced. Here on you can write NH2, here you can write NH2. So this N and this N attaches to this carbon and urea is formed. Very important. Another, you can also classify this as an acid base reaction, because this is base, this is acid, water, salt. Happy? Acid base reaction. Huh? Normal reaction, nothing much. Next, we are going to study about combustion of ammonia. See, while we will be talking about combustion, definitely we are going to talk about two kinds of combustion. Number one is without catalyst, 4NH3 plus 3O2 gives 2N2 plus 6H2. Okay. Here the flame color is, while this thing takes place, the flame color is greenish yellow. Okay. Now this is normal combustion. This is an important part, that's why I have written this is normal combustion. Now what happens when this combustion takes place in presence of catalyst? That is catalytic combustion. This is very important reaction. This is used in Oswald process, preparation of nitric acid, industrial manufacture, I would rather say, 5O2, okay, platinum 800 degrees Celsius, okay, 4NO. This is an exothermic reaction, 6H2O plus heat, exothermic reaction. Okay. So this is a starting reaction of, you can write down, this is a starting reaction of Oswald's process, which is basically used for manufacture of ammonia, sorry, nitric acid. Okay. In this reaction, some part of NO gets converted to NO2, some part. So some reddish brown vapors are produced. Some part of NO gets converted to NO2, so some reddish brown vapors are produced. So it can act as an observation in this reaction. Very important. Okay. So this basically culminates the reaction part of gaseous ammonia. This culminates the reaction part of gaseous ammonia. But remember, we have also studied another kind of ammonia, right? That is liquor ammonia. So what happens to liquor ammonia? Liquor ammonia was what? Liquor ammonia. Liquor ammonia was nothing but NH4OH. In case of reaction with acid, I'll just show one, NH4OH plus HCl. Definitely it will give you salt plus water, NH4Cl plus water. Similarly, it can react with HNO3 and H2SO4. For other reactions of this liquor ammonia, please refer the video on analytical chemistry. All the reactions of liquor ammonia, that is NH4OH, I have covered under analytical chemistry. Please go through them very well, because those are part of analytical chemistry and very important for observation type of questions. Very important for observation type of questions. Okay. And also very important for various tests. Like for ammonia, there are certain tests. For ammonia, what are tests? What are the tests that are important? See, number one test is definitely with HCl. It gives dense white fumes. Okay, we already have learned this. With Cu2 plus salt, what happens? फास्ट क्या होता है, पेल ब्लू प्रेसिपिटेट देता है, पेल ब्लू प्रेसिपिटेट देता है। एक्सेस NH4OH देखो तो excess NH4OH if I add in this, then what happens, inky blue solution, inky blue solution, formation of tetramine copper sulfate, we have already discussed this. What happens with Nessler's reagent? Now what is Nessler's reagent? Somebody can ask me what is Nessler's reagent. See, Nessler's reagent is nothing but K2HgI4. This is Nessler's reagent. Definitely it has to be alkaline, it has to be alkaline, it has to be alkaline. It gives a brown precipitate. Ammonia gives a brown precipitate. How do it give? The reaction I'll just show you. AgI4 plus 3KOH plus NH3 will give you NH2 Hg O Hg I plus 7Ki plus 2 water. Okay, this is called iodide of Milon's base, and this is the brown precipitate. This is brown precipitate. Okay, okay guys. Next one, we need to discuss about some uses of ammonia. Exceptionally used in many places. Very important compound. It is used in fertilizers. Okay, because you must have heard about NPK fertilizers. Just now you have learnt about urea. There are compounds like NH4 whole twice SO4 which can add lot of nitrogen in the soil. Next, it can form lot of explosives like NH4NO3 is an explosive material, we have already seen. Okay, we have seen explosives like NCl3. Then there is another very important explosive, that is NH4NO3 plus trinitrotoluene. This is trinitrotoluene. Okay, trinitrotoluene, TNT, trinitrotoluene. Okay, so this total mixture is called ammatol. This total mixture is called ammatol. Next, very another two important one is, that is which is used vehemently, ammonia is used as a refrigerant. Why ammonia is used as a refrigerant? Please write down. It is highly volatile, highly volatile, number one. Number two, it has high latent heat of vaporization, high latent heat of vaporization, very high latent heat of vaporization. And number three, liquefies easily, liquefies easily under pressure, under pressure. ठीक है, liquefies very easily under pressure. ठीक है. Next is it doesn't deplete ozone layer, so it is environment friendly, right? It doesn't deplete ozone layer. ठीक है. So definitely the question will come, then why don't we use ammonia in our ACs or refrigeration unit that we use in our house? The problem is ammonia has a very pungent smell, very pungent smell. A small leak will cause a very pungent smell all over the house. So that is why it is not used, nothing else. But definitely it is used in industrial, as an industrial refrigerant, places where, like I could say you, this ice cream factories, they use ammonia refrigeration units. Then this potato storage, okay, food storage, they use ammonia refrigeration unit. Okay, so this kind of places, the cold storage, basically these potato storage places where the vegetables are stored are called cold storage. Okay, So only problem is it is having a very pungent smell. So, now, so that is why what we did, first of all we were using some CFC in the CFC का एक trade name बता देता हूँ R22. So CFC in where we are using CFC in your various refrigeration unit, like our own refrigeration unit in our house, then your ACs and all. After that, as it was ozone depleting, we just replaced it by HCFC, hydrochlorofluorocarbon. And nowadays it is much more safe as an alternative, but still ammonia is used. Okay, ammonia is used in cold storage, ice cream factory and all those places, and it is used very vehemently. So if you need ammonia refrigeration unit, you can contact this company. I'm not means advertising for any company, but they supply a lot of refrigeration unit based, ammonia based refrigeration unit with this cold storage guys, or this ice cream factories and all. Okay guys, thank you. That ends the ammonia part for ICSE syllabus. I hope everybody of you enjoy it, and definitely will get great marks, at least whatever question asked in ammonia. Thank you.